So in this example here, we've been given a sine function, y equals sine x. And if we take a close look, we can see that there is one full period of sine. We start at 0, and one full period of sine goes from 0 to 2 pi. And then we go beyond that. So we've drawn more than one period here, but that is y equals sine x function. We've been also told that we have a y value, or a sine value, of 0.783. So I've drawn a horizontal line at y equals 0.783 to represent the sine value of 0.783. And we can see that the original coordinate that was marked, and it's a little bit hard to see because I've drawn all over it, but the original coordinate that was marked in the question was at x right there. And we've been asked to find all the other points where it equals that same value. So I've marked them in green and red. So that first coordinate is at x equals 0.9, y equals 0.783, and then we have the green ones and red ones which represent the same y values or the same sine value. Now there's a reason why I mark them in green and red, because the green ones are related to each other and the red ones are related to each other. And they actually relate to the green being theta 1 and the red being theta 2 that we learned in standard position. Now if we take a look at this, if we look at starting at 0.9, the original green x here, and we go all the way to this next green x. Now, if we trace the line, we're going to go through one full cycle of that sine function. Although we didn't start at 0, it still represents one full cycle or one period. So that means that the distance, the horizontal distance between those 2 points is going to be 2 pi. So we've moved plus 2 pi to the right from one to the other. So that they are in fact coterminal angles. They are the same position angle, but in different periods. We can also go backwards from here to here. And if we just trace that out, that's going to be, again, one full circuit or one full circle. And that also represents 2 pi. So that distance going from backwards is going to be, we can subtract 2 pi to get to that position. So again, those are coterminal angles. They're the same position in the standard position circle, but they're the different periods. So we can start coming up with a solution for this, the angle values that give us the same y coordinate. So we can call that theta 1. Theta 1 was 0.9. And then we had another theta, which was 0.9 plus 2 pi. Okay, so that represents another angle. Okay, and we have another angle, which we go backwards, so 0.9 minus 2 pi. So these angles are related through their period. Okay, they are all related through just the period, so that's why they've been all marked in green. Now there's another angle here in red. Okay, and I'm just going to say that that is theta 2. This is actually related to theta 2 in the standard position. Now when we take a look at that red point, how is it related to the green point? Well, we can use some symmetry. And if we can measure 0.9 from the right, okay, so maybe I'll just point that out here. So 0.9 to the right from 0, that same distance we can see is going to be 0.9 to the left from pi. So just writing that in, I can see that this little distance in there is also 0.9. Now that is a distance, it's not a position. So to find the angle position, we can start at pi and subtract 0.9. And in fact, that is theta 2. That was the formula for theta 2 for sine. It was pi minus 0.9, pi minus theta 1. So that angle position then, when I write it out, is going to be pi minus the original position of 0.9. Okay. There, when we take a look at that, then if we move on to the next red coordinate, That, if we trace out the curve, is going to go through one full period again. So going from one to the next, we can start at pi minus 0.9, so that's our starting point. And then we're going to go forwards to pi. Okay, so simplifying this becomes 3 pi minus 0.9. And we can do the same going from the first right coordinate. We can go backwards, and that is also 2 pi. So we have the sixth coordinate is going to be pi minus 0.9. And then we're going to go backwards 2 pi. So when we simplify that expression, we end up with negative pi minus 0.9 as the angle position on the x-axis. Okay, so that would represent this position right here, last one that I did. That position is negative pi minus 0.9. And we can see that if we start at negative pi and we go backwards 0.9, we're going to end up at that x position that gives us the sine value of 0.783.